Well, it is given that the probability of events A and B occurring are denoted by probability of A and probability of B, respectively. For any two events A and B, it is given that the complementary probability of I'm saying the probability of the complement of B is 0.28. The probability of B is 3 times probability of A. The probability of A and B, A or B equal to 0.96. Are events A and B mutually exclusive? Justify your answer. Well, on our right here, question 10.2. So we're doing 10.2. Now the question is to prove that the probability of A and B are mutually exclusive. So two probabilities are mutually exclusive if the intersection is just equal to 0. Okay, it's like if we have like one circle there and another circle there, so no intersection between the two probabilities. So something like this, one Venn diagram there and one, so there's no intersection between the two. In other words, for if the probability of A, we are asked to find that, to prove that the probability of A and B equals 0. Now, how can we do that? We need to find what is the probability of A, okay, and the probability of B, the probability of B, and now, well, how can I find them then? All right. Okay, first of all, okay, as I said, we need to prove that the probability of A, the probability of A and B is equal to 0. If I look here, I have the probability of the complementary of B. So we know that the probability of B then will be equal to 1 minus the probability of B prime. Okay, so this will be 1 minus B prime is given by 0.28. So probability of B is just equal to 1 minus 0.28, which is 0.72. Now, we also, now that you find the probability of B, can I find the probability of A? Oh, okay, if you say that the probability of B is equal to 3 times probability of A. So we can find the probability of A, since probability of B equal to 3 times the probability of A, so we can just and then B is given by now 0.72. So this is 0.72 equal to 3 times probability of A. Now, if I need to find the probability of A, I can just divide by 3 and then solve both sides. And then this would be 0.24 equal to the probability of A. Now we know that the probability of A equal to 0.24. And then also, now that we know the probability of A and the probability of B, we can apply these other properties that say the probability of A or B, because we do know, I need to prove this initially, but I do know that the probability of A or B, now right here, the probability of A, okay, let's move the board so we can have enough space to write. So I'll move it over here. We do know that the probability of A or B equal to the probability is, this is given by the probability of A minus B. So I'm gonna say, oh no, A plus the probability of B minus the probability of the intersection, okay? A and B, this is where I can get an A and B. So I can just move this formula a little bit over here. Yes. Now, here is the formula. So we do know that the probability of A is just excuse me, 0.24, and the probability of B also is found by 0.72 minus the probability of A and B. And the probability of A or B, which is the probability of A union B, was given is 0.96. It's here. 0.96 over there. Okay, now this is 0.96. Now, if we do 0.96 equal to 0.20, that makes 0.24 plus 0.72. This also makes 0.96 minus probability of A and B. Now, we can simplify this one. We move the 96 over, and then we have like 0 equal to negative probability of A and B, which is just 0 equal to the probability of A and B. And this is proven because we had to prove that the probability of A and B was equal to 0 in order to have a mutually event. Thank you.